Welcome to Samba Samba. Enjoy the video.
You start by listing every charge and marking their coordinates. Do this immediately. Next, set an origin and write each position vector Ri and the field point Rp so you have displacement vectors Rp, Ri. Then compute the distance r equals Rp, Ri and the unit vector equals Rp, Ri/r. These steps let you apply Coulomb's law directly. Make sure units are standard, meters and coulombs, before calculating magnitudes. Now compute each electric field contribution. For every charge, use EI equals K asterisk QI/R2 and multiply by the unit vector to get the vector EI. That preserves direction. Resolve EI into components by multiplying magnitude by Rex, or Y or Z. Use algebraic signs. If QI is positive, the field points away. If negative, it points toward the charge. Once done, write numeric component values with consistent units. If angles are given, convert to components with cosine and sine. Finally, add all component sums to get E net x, E net y, and E net z. This is superposition, simply algebraic addition. Then compute the magnitude as the square root of the sum of squares and form a direction unit vector if needed. Make sure the result carries units n per coulomb. If something seems off, recheck signs, distances, and unit vectors first. Common mistakes are swapped r, n, or missing negative signs. Troubleshooting tip: if magnitudes blow up, check for r equals 0 or misplaced coordinates.
Thanks for watching. Consider subscribing if we helped you.